Hello, everyone. I am Steve,
And I'm Scott.
and together we're Backyard Musings broadcast from Apple Valley, California.
Science and Technology Channel.
All right, gamers, listen up. Tired of that laptop overheating during intense battles due to graphics overload? Mm-hmm. Well, you ain't alone. RIKEN scientists have discovered how to manipulate molybdenum disulfide into acting as a superconductor, metal, semiconductor, or insulator using a specialized transistor technique. By inserting potassium ions in adjusting conditions, they could trigger dramatic changes in the material's electronic state, unexpectedly, even turning into a superconductor or insulator. This new level of control over a single 2D, two dimensional material could unlock exciting breakthroughs in next gen electronics and superconductivity research. Would you like to know more?
A team of physicists at RIKEN have developed a transistor based technique that allows a single layered material to take on a wide range of electronic behaviors, functioning as a superconductor, metal, semiconductor, or insulator. This approach could lead to the discovery of new superconducting materials. Quote, the variety of electronic properties based on a single material is highly intriguing to us from a materials science perspective, says Yoshihiro Iwasa of the RIKEN Center for the Emergent Matter Science, who led the study. Emergent Matter Science. Okay.
Yep. The material in question is molybdenum disulfide, MOS2, which can be isolated into atomically thin layers. Each layer consists of molybdenum atoms sandwiched between layers of sulfur atoms. Depending on how these sulfur atoms are arranged, MOS2 can exist in two different structural phases: the 2H phase, which behaves as a semiconductor, and the 1T phase, which acts like a metal. Quote, 2H molybdenum disulfide is highly promising for use in next generation semiconductor devices, notes Iwasa.
To explore how the material shifts between the phases, or shifts between phases, the researchers built a field effect transistor and connected it to a sample of 2H phase molybdenum disulfide by adjusting the voltage applied to the transistor. They were able to control the insertion of potassium ions into the material with high precision. Okay.
As the potassium concentration increased, the material abruptly transitioned from the 2H phase to the 1T phase. This change occurred when there were approximately 2 potassium ions for every 5 molybdenum atoms, highlighting a clear link between ion concentration and phase behavior.
Then, by inserting the right amount of potassium and cooling the sample to 268 degrees Celsius, the researchers found that 1T phase became a superconductor.
Although superconductivity had previously been seen in the 2H phase, this was unexpected for the 1T phase, and it occurred at a different temperature. The biggest surprise for us is that we observed superconductivity when we introduced potassium ions, says Iwasa.
More surprises were in store. The material switched from being a metal to an insulator when the researchers allowed potassium to leak out of the 1T molybdenum disulfide until it contained relatively low levels of the ions and set its temperature at negative 193 degrees Celsius. We found this interesting, this is a quote, we found this interestingly because we didn't expect this phenomenon to occur, says Iwasa. These results demonstrate that introducing potassium ions in this way is a powerful method for controlling the structure and properties of two-dimensional materials like molybdenum disulfide.
Quote, we've been developing this method over the past decades, says Iwasa, and we've shown that it is useful not only for exploring novel properties of superconductors and related electronic phases, but also for discovering new semiconductors. This article appeared in the journal Nano Letters, not making that up, on October 21st, 2024.
So molybdenum is a pretty rare metal, I guess, and it's pretty strong. And it's, from what I understand, it's flexible. And If anybody knows different, please let me know. But I'm pretty sure, because I remember a buddy of mine was building a sandrail. Are you familiar with a sandrail? It's like a go-kart, but you put a big mast on it and attach a sail. You take it out on a dry lake, and the sail propels you. The wind and the sail propel you.
So
And he
how does it go across the sand? Is it on runners?
dry lake,
Wheels.
like a dry lake. Yeah, it's got wheels. It's like
Wheels. Okay.
a go-kart. I mean, they make them 4-wheel, they make them 3-wheel, triangular shaped. It's kind of it's a weird deal. So, but anyway, he had one of these, and he was wanting to find out if he could find a mast made out of molybdenum, because it was flexible. He had a mast before, and it broke. The wind, one time he took it out, the wind broke it, his mast. So,
Wow.
but yeah, so pretty rare stuff. Pretty rare stuff. I know of one mine that mines this, and I'm sure there's more, but it's considered a rare metal, I think.
Yeah, so I guess that would drive the price up of a gaming laptop.
Yeah. Yeah, so find a different hobby.
Yeah.
So.
No.
All right.
I'm not finding a different hobby.
You're not. All right. Okay.
All right, folks. Thanks for joining us.
Take care. We'll see you tomorrow.